2-12, and this is the way 2. So the second way I detailed in the video, and this just kind of shows you through the way the book did it, which is kind of the same way. Same with here. And at the bottom in C, you're just getting that final equivalent circuit where V total equals I total R total, and that gives you the full current going through. So that's going to be 4 amps. So again, it doesn't really matter if you do method 1 or method 2 or which delta you take. You're going to get the same answer of I equals 4 amps anyway. So here we've got our final bit of equivalent circuits roundup from this. So I'm just going to walk and talk through these with you. And you've seen most of these already. You've seen all of these already, actually, in videos and examples, but I think it's good to kind of quote through. So the very top left, we have a circuit, 2 resistors, R1 and R2, that are in series. And therefore, the equivalent resistor is 1 resistor with the total of R1 plus R2. That's easy. So the next one, we have 2 resistors in parallel. This is another easy one. The equivalent is a single resistor with the R1 times R2 on the top over the sum of R1 plus R2. And this is the same as taking, if you have a whole bunch of resistors in parallel, you can do 1 over R1 plus 1 over R2 plus 1 over R3. Take that whole group, however many you have, and then bring it up to the -1 power, and that's going to give you the same equivalent resistor too. So that simplifies into 1 resistor. The one underneath that, we've got 2 voltage sources. Both of the pluses are facing the same direction. Both of the minuses are facing the same. So the negative goes to the plus and the plus goes to the negative. And that means we can add that into a single voltage source, which is the sum of both V1 and V2. On the bottom, the next one down, we have 2 current sources which are in parallel with each other, both pointing the same direction. And so because all of the current into a node has to equal the current going out of the node, we've got a nice little equation there, which means that is the sum of R1 and R2. And then underneath there, this is the one we used a couple of times to get different, if we get a current source in a problem. This is that transformation to bring the voltage source to a current source and the current source to a voltage source. So if you have a voltage source and a resistor right after it, you can transform this into a current source in parallel with a resistor, and vice versa. So this works backwards too. If you have a current source with a resistor in parallel to it, you can transform that back into a voltage source with a series resistor. And we did a really good problem, remember, bringing it back and forth a few times to be able to solve for that. Finally, on the right-hand side, we have a Y to delta conversion here. And again, it goes Y to delta or a delta to Y. And these are reversible. So underneath there, you're going to see the R1, R2, R3, and the RA, RB, RC, so that you can always solve given the other one. So usually, early on here, we're going to have a lot of deltas, and we're going to bring them into Ys. So that means we're going to have to solve for a lot of R1, R2, R3, because we're going to have a lot of RA, RB, RC. And that's like the problem we just did in example 212 not too long ago. So those are the equations for that. And again, I'll show you as we go through a couple more tricks to remember them so that you have these memorized. Everything on this slide you should understand and have memorized. I don't think we're going to do any note sheets on tests. So with that being said, I wish you happy study.